Today I'm going to talk about pliable systems architecture. So if you look at the dictionary, pliable refer to things that's easy to bend. When you talked about people, it's easy to influence them. Our keynote speaker talked about malleable processes, but the underlying topic that I want to talk about is actually change. So let me start with a story about change. So in 2013, we started a vehicle telemetry system applying the principles that I'm going to share with you today. So in 2013, we ventured into insurance telematics, where you can show to your insurer who's the good drivers. We suggest you should reward them, and then on the high-risk drivers, you should actually kind of manage them. We also did accident reconstruction. So in this diagram, you can see that this vehicle had an impact from the right front, and the insurer should repudiate any claims regarding scratches on the back. So then we moved on to the same system we used for ride sharing and driver score gamification, family fleet, and for the young professional, a travel logbook. We added work items, European bikes, and the small to medium business fleet. So today on this platform, we have 220,000 active users, 360,000 vehicles that's being actively monitored, and we process around about 90 million records a day. Okay, so as you can see, change is inevitable. People have ideas, we try them, sometimes they work, sometimes they don't work, and in the cases where it doesn't work, we want to try to align what we've built with what actually is working. Of course, our users love more features. Our product managers, they just want to throw features at us. Your environment also changes. For example, the services that we consume, the databases, APIs that we make calls to. Sometimes the hosting environment changes. We moved this platform from our data center, which used VMware, to Microsoft Azure in Johannesburg North. And that was also a big change. And there's always some form of maintenance that needs to be formed. Libraries get outdated. There's always a little bit of code debt or technical debt. And we want to be agile, and the Agile Manifesto actually states that we embrace change. And we also want to build our software and our architecture so that we also embrace this change. I want to note 5 things that make change difficult. I mean, there's a lot of complexity. Sometimes some people build code before you that is or was complex. Testing makes change difficult. Not always having visibility into what your software is doing. For example, if I apply a change, will it improve the performance of my system or not? So that's where we make sure that we have performance counters, logins and tracing. The release process can be difficult, and sometimes the sheer scale. I just want to talk on the first 3. Okay, so one of the ways that we use to manage this, make it easier to change, is using microservices, so you can break up your system component into smaller pieces. So here's an example of this system where we receive data, and then between the top services, we use queuing so that the services can communicate with each other. And then at the bottom, you see an API with various user front ends. So using these separation of the microservices, for example, through queues allow you to inject let's say, test data so that you can see each service is working or not. And then at the bottom, the API also allow you to have different front ends, different views. For example, on the one hand, you want an optimization view where your fleet partner wants to optimize their fleet. And on the other side, they want to have a risk view, but they can connect to the same API and have the different views, but the same underlying data. Okay, so let me show you a quick testing production. So we can take this message, and I can use that communication microservice, and I can send a test message to myself. Let me open. Okay, so there's the message that I sent to myself. So if we could just go back here. So I've confirmed that that communication microservice is working. If there's an issue, I can then test each microservice individually. I can also test my API, and I can show that the API is working. In this case, I'm just getting a list of vehicles and their current location, and I can show it's working. So if there's an issue, maybe the issue is with one of the front ends and not with my API. Okay. So if we quickly go back here, if you take that convert and data filter class, so that service, what it does is it receives data in various formats, because we have got different IoT devices that report in, and it just convert it into common format and then filter out. Almost the natural way to implement that is to build a quick class doing that, because it's quick to write. For me, this is a kind of an anti-pattern. The God class, all-knowing, all-seeing, omnipotent class. And I think the thing that's difficult there, it's difficult to test and maintain. And if you do a lot of changes, it kind of turns into this spaghetti code monster. So what we've done is we use the solid principles and aspect-oriented programming, because it's language and technology agnostic. One of the things that I personally found about the solid principles is it's misleading simple. I mean, you see it, and then as time goes by, you get a lot of pressure from business to get stuff out, and it goes out by the door. But it took me about 5 years to get applied consistently. Okay, I'm not going to stop there. So in my first demo here, I took that service there and took the different parts of it, and I broke it into smaller pieces. First, the threading, then reading from a queue, deserialization, do the conversion to common, having my data filter, and then pushing it into a queue with some data context. So I'm just going to show you some of my code here. So in my configuration, I set up my worker queue. There's a queue reader that it reads from, and it must call the tqueue method constantly. So I separated those pieces of my code. So my queue reader, all it does, it's reading from a queue. My data filter, convert to common. So let me just quickly go to the configuration here so you can maybe understand better. So I've got 2 different types of devices. I pass it in here in the converters, and it will use these names in this dictionary pass here to do the select the right conversion. And if you look at the data filter class, it's all these classes are very simple. And I'll show you now why. Just to show that everything is working. I say here's my device A, and I'm going to pass it into, I'm going to push it into this queue here, and it will do some conversion and put it out there. Okay. Maybe let me just put a breakpoint there also that you can see. Sorry. Okay, and then if I push, just going to clear it here. If I push the data in here, you can see that this message that comes in, it comes from a device type A. I could pass my converters here for device A and B. It does the conversion. Then it checks if the these devices that I'm looking here is in the database. There is one of these devices in the database, and then it will pass it through. Okay, so as you can see, it's much simpler to test and verify, and the parts are kept separate. Okay, let's carry on. So when we initially, you should see the previous example was when we were in our own data center. So when we moved to our Azure data center, there were other queues that I needed to consume from. So if you follow this approach, I only needed to replace three classes there, and I didn't touch anything else. For the sake of time, I'm just going to show you how to change or swap out that XML deserialization to JSON deserialization. Okay. And it's only a configuration change here in the So I replaced this XML serialization with JSON there, and just to show you that it's actually working, I can take okay. Just want to clear this quickly, and then if I push the JSON in here, it still does the conversion. Still the same code that runs, and I haven't actually changed my core code in any way. Okay, I just want to stop here. Okay, so if I now going to build the rest of my environment, my architecture, as you can see, the plumbing stayed the same. I've got a data importer here. It's the only part that I changed. It's the only part that I write new. Same, we've got a service that does data aggregation. For example, we call it a trip, so your ignition on to ignition off. It aggregates those into their own data records. As again, you can see the rest is the same. It's just the plumbing is the same. So we got an alert processor and communication, and you're following that same principle with that passing my different converters or different communication mechanisms with just a dictionary with a name in. I can now build these different mechanisms. So if you think back look at the code, your different parts of the code, it doesn't care where the data comes from. It doesn't care where, if you do ask an interface for data, it doesn't care where it comes from or where it goes to next. and your code still remains quite simple. Your business code can focus just on your business aspects. There's a lot of reuse, and most of the time, most of the change requires just a piece of new classes. And there's no highly coupling between your different parts. Okay. I think the other thing that it's also important is testing. If you can test it, it's easy to get your code out. And one of the things I believe is if it's difficult to test, you're actually doing something wrong. So if we go back to this, this data filter class, because it's so simple, you can almost visually quickly inspect and say, okay, what's it doing? And you can say, oh, I'm missing, I should check for a null here, check for a null there, and here's two exit points, so we need to test for 2 paths through this execute method. Just quickly going to add my check for null. Sorry. So in this case, you can decide whether you want to throw exception if you get a null value, or you can, if you can handle it. Sorry, just copy, put it in there. I can now put in a piece of code there that handles if there's a null value, and now I can go and test my test this through unit testing. Just something quickly here also, because the code doesn't care where this data context connect to. Immediately it allows you to mimic or mock it. So I'm using the Microsoft fakes here, and it creates a stub for you, so you can now override this retrieve method. In this case, I'm simulating where the database, the device doesn't sit in the database, so it will return an empty list here. And in this case, I'm simulating where it finds the device in the database and it returns it. And in this case, I'm testing for these null values. So as I said, I'm testing for this null value. In this case, it's not throwing exception, whereas in this case, it actually checked for an exception on the test. So I'm checking if this part is null. So let's quickly run it. Okay, sorry, I should have ran it without. Okay, test for that. Okay, and there, as you can see, all my tests were successful, and I have for that specific class where I can 100% code coverage for testing. Okay, let's move on. So I think the other thing that you may say, your code doesn't have any logging and tracing in. I mean, real world code does have logging and tracing in. I prefer just to not put my logging and tracing, or letter my code with logging and tracing. I just I inject the logging and tracing in afterwards. So using the injection method here, I've injected then just after my JSON DCR, I'll inject a tracing tool, and after, to the data context as well as to the part that goes on, and we'll also trace the performance. Okay, so let me quickly show you how I would do it. So I've written here let me just see. Okay, so I've written what we call a trace behavior using the Unity, and it's a very generic method just to determine what, write to the performance counters the name of the method that I'm trying to trace, and all the detail of the arguments that went through, and then the performance behavior basically does the same. I'll quickly just show you how I inject it. So on this data context, I'll add the interception for tracing and performance. I'll do the same for for the data filter, and I'm doing it here as well. So if I run the code again, okay, I'll just go get some JSON to put into the pass into this queue. Let me also just show you what's happening now. Okay. So as you can now see, I've added logging and tracing. So between those methods that's been called, it injects itself, and now I can see what data flows between the data without writing any logging and tracing within my business or my plumbing code. And I've also got a performance trace that can show that the show rate and duration that I also inject there. And then the instance names here is then link the class and the method that is being called. I think the last thing that we also can do, because you're working against this interfaces for your data context, I can now go and build a data context with cache. It refers to a caching mechanism itself, and I've got a worker thread that runs every 20 seconds and tells the cache to clear its expired items. So again, the caching itself is simple. The threading sits outside of itself. It doesn't need to know about it. Just to show you quickly. So I've okay. So my class here inherits from this data context here. I pass the actual data context that I would like to cache the data for. And in the three methods where there's an update, I just want to get the caching in here for the retrieval. Okay, so to configure that, okay, let me quickly go here. Adding it here, and then the so I tell now the data filter class, instead of connecting directly to the data context that speaks to the database, first go through this caching mechanism. I just want to stop here. So the reason why I like this is in some cases, it makes sense to put in cache. In some sense, it doesn't make sense to put in the cache. But at least for the places where it needs to, you can go and configure it like that. And it's not a total rewrite each time you have these different connectivity to the database. Okay, so I'm just going to get this. Just going to clear this here, and just want to put this in front. So I can now push in some data in here. The you can see that the rate and the duration. So the first few times the first time it took long, and the second time it got the data. It got the data from the cache, and it was fast. Okay, let's get back here. Okay, so as you can see, your code doesn't need to be littered with a lot of logging and tracing and a lot of stuff that's not really core to what your programming is doing. The other thing that I also found is sometimes logging and tracing, writing to a trace file can be slow. So then you can only add it when you need it, and not have it there all the time. And your code is much simpler. The other great thing about this way is, instead of if I want to move to another performance logging like Grafana, or log my tracing data somewhere else, like a SQL database or wherever, it's just that class that I replace, and I don't need to go through my whole ecosystem of code to replace the my logging and tracing. Okay, so I think I've showed you that overall simplicity here. Code that's very generic, and I think the other important thing is, if you use this solid approach, you can start off with existing frameworks just to get off the ground, and then as necessary, you can replace them. For example, we used Link to SQL initially for our database connection, and then at some point we needed to build something faster to actually keep up with the data feed that we get. We also reduced your test surface, so it means that testing is much shorter. There's visibility in what your code is doing internally, and I think overall it is easier to the code was easier to change, and means that you can deliver quicker and often. And yeah, please rate my talk here. Apparently, you can win a Wi-Fi-enabled robotic vacuum cleaner. Is there any questions? Okay. I don't see anything on Slack yet. Yes.
Sorry, if you do, please can you just give them the max of the stream and also I like the demo. Thanks for that. My question is, with this amount of configuration or configurability that you have, there's a heavy reliance on reflection in the background.
So I'm using the Microsoft Unity dependency injection framework. So what I also initially started with my code where there was a bit of dependency on the framework, and then eventually I learned to build it that there's no, the code shouldn't be aware of the dependency injection framework.
Mm. But there is a use of reflection, like inspecting, like you had a process link, square brackets.
Yeah.
So there's reflection happening in the background.
There's some reflection happening within the code. For the interception, I saw what they've done is they've used the intermediate language. So it's almost like taking C# and compile it during the runtime, so that it's almost like you're using actually compiled code.
And how does that use of reflection compare to not having reflection? Because using reflection has a performance impact.
Yeah, sorry. They use reflection when they initiate the classes, but if you look at the code for the interception, it actually builds intermediate code as if you coded the code once, then they cache it, and then it actually is as fast as statically writing the code,
Okay.
but without the writing all that code. So it's fast.
And a follow-up to that question is, how maintainable is this code? Because if I have to change process link to something else, I'll have to then go to the configuration and change every reference to that. Because compiling doesn't show you that
Yes. So
XML
I
needs to change.
I think there is a bit of, let's say, understanding the Unity framework, and the initially when they gave error messages, it was difficult to figure it out. But once it's running, you can now start swapping out different parts of the code, or you can up your number of threads, down it, decide whether if you start up a new worker thread, should you start one user thread and just one of everything, and I have multiple threads working on that if you got reentrant functions, or should each worker thread have its own set of classes that it refers to? So yes, there's a lot of configuration, but it actually makes it easier in the long run because your changes are small and maintained. You can actually, while you're, let's say for instance, building a new class, you can check in your code and it can go to production, but that's not enabled until the moment you swap it out.
Okay, thank you.
Yes. Any other questions? Or was it too much too fast? I know each of these topics, like the microservices and the solid and aspect-oriented programming, actually require a talk on its own. Okay. From the previous presentation, there was some questions about how do you get this in your team, this mindset. And I think that what I've seen is we spend a significant more time on maintaining code after it's been written than really building new stuff. So you must make it easier for yourself to change your code. And I think the other thing that I've also seen is that there's a big difference between just writing code for quickly writing and getting it out into production than writing code that's easy to change afterwards, easy to visually inspect and to see, okay, that it's going to work or not work, and to make it so that you can test and change it as well. Okay. So if there's no further questions, I'll be here to chat afterwards.